opportunity here to make a big impact on people's lives, which I'll get into a bit later on. Get my transition to go. So what do we do at Flip? So many people really know us from the Flip app. So the Flip app is available on the iOS and Android store. It's really how most people know us. But really what we are is all about reinventing the shopping experience. So we have been looking at how we can do visualized merchandise when we look at what the store experience is. That's what retailers really care about. How you can visualize the merchandise that's available in the store. How do you plan and pre-shop when you're actually putting together your weekly shopping? So we looked at reinventing the shopping list to really make that easy for people. Recently, we've been looking at e-commerce integration. So how can we have a connected shopping cart with our retail partners to make Flip the easiest place that you can go to do all of your shopping? When we did a partnership with P&G and we launched in a few months ago what we had called the Coupons 3 launch, which was really about giving broader availability of coupons. So coupons in Canada aren't really a big thing, but if you go in Flip now, in Canada here, you can find a number of coupons that are actually through photo receipt. So you can select the store you want to go to and take a photo of your receipt for the item, and we will reimburse you through PayPal. And so that's one of the things we're looking at, of really trying to make saving money as easy as possible for all of our users. And what it really comes down to is Flip being a marketplace. So Flip is a sort of three-sided marketplace. And what it comes down to is there's the retailers who want to sell their goods. There's the manufacturers who are making those goods and giving them to the retailers. And then there's the consumers who are looking for things to buy. And what we really strive to do at Flip is to build a cohesive marketplace where everybody wins. We're always looking for win-win-win scenarios where the consumers can find the best price, the manufacturers are able to move their product as quickly as possible because they're able to give a good price, and the retailers are also able to win by people actually, in some cases, purchasing more when they go to their stores, but certainly helping to move products when they're working with their manufacturers. And Flip is not just the app. It's really what most people think of us, but really the Flip app and the marketplace is sort of in the middle, but we also have media partners with Facebook, Google, Bing, MSN, lots of other places where we actually have a media partnership where we're able to get content to millions of users. From the retail side, we partner with most of the big retailers in North America. Most retailers that you can think of in North America, we have a relationship with, or have a relationship with Flip, and we are either powering their own flyer website or promoting their content on Flip. When it comes down to what we're trying to do in the app, the big thing is the landing page, the browse screen, where you're able to find all of your local flyers. From the coupon perspective, really making it easy for you to find the coupons that you want. So this is actually a screenshot from what we have in Canada today, and I believe this coupon is still valid, as is that one. It's 75 cents off Shreddies, sent right to your PayPal account. And next, we really looked at making the shopping list really, really easy and simple to use. So we have things like you can take a photo of a handwritten shopping list and it will be transcribed and added into your shopping list. And also any item that you add here, you're able to find all of the deals in your local flyers. And it's really about helping people save money and making it very easy. A little bit about the team. We are currently over 400 people now. I think last year when Myers gave a very similar talk, we were probably at about 250 or 300, so we're growing very rapidly. Right now, we have about 130 plus people in our product and engineering team, not including our large volume of students that we have. And last spring, we had a strategic investment from General Atlantic. This was a strategic investment that's really helping us power more partnerships, as opposed to, say, keeping the lights on. And General Atlantic has previously partnered with, I believe, Airbnb, Spotify, and Uber, I think, companies like that. So a little bit about our mission that I touched on earlier. What we really want to do is help families save money every day. And what I believe we hear from our users is they save between 20 to 40% off of their weekly shopping by using Flip. And really what it comes down to for us when we were looking for great people to join our team is whether they fit into what we call our 3 H's and our EBCs. There's the 3 individual characteristics we look for in every person. It's being humble, so you're able to actually, it's kind of one of the prerequisites for being able to have the open trust that I talked about. You're hungry, you always want to improve. We're very big on personal growth here at Flip, and highly intelligent is a given. We're looking for very smart people. Then we look at the ABCs, which are our team-based principles that we look for from every person in terms of how we want people to behave in a team. It really comes down to always reinventing, meaning we look constantly at what we're doing and how we're doing things to see if there's a better way to do it. And that goes from end to end within the company, whether it's the product, a process, anything. We're always looking at how we can improve. It really comes down to, again, our hunger to constantly be improving. Being team first is another key one that we talk about constantly. It's about putting the needs of the team above your own. It's about supporting the team as needed. And it's also about, if you recognize that there's something not quite right with what is a direction or what's being talked about, you speak up about it. It's not just, oh, I'll roll up my sleeves and get this thing done. Being team first is really about making sure that you are raising your concerns to the team and make sure that we actually pick the right thing. And finally, the third one we look for is people who are interested in coaching others. Coaching is at the core of our company. We actually don't call people managers here, we call them coaches, because the expectation is that as a leader, we actually call it servant leadership. So servant leadership is not the top bringing things down in a kind of a typical hierarchy perspective. It's about the leaders doing what is needed to help their team succeed and help their team grow. So what's often talked about within Flip is this term called and it's really broken down into two things. To rush along in unison. It's about being of one mind and really rushing towards a common objective together. And if we have high trust and we're able to have a good, healthy debate about what the right thing to do is, then we can all commit that, okay, this is what we're driving for, and we're going to go at it really hard and help us move really quickly. So the classic example that's used is like a dragon boat, where if every person here is working in unison with one goal and paddling together, they're going to go really fast and be very successful. If everybody on that boat is doing their own thing, going at their own rhythm, they'll go in circles, they'll go all over the place and won't really meet their goal. So that's really what it comes down to. So like I said, I welcome all of you to Flip. Please help yourself to more pizza and drinks and have a great evening with all the challenges. Thank you.
Thank you.
With that, I'll pass it back to Armando.
Thank you. All right. Awesome. Thank you, Patrick. Here. Oh, okay. I thought you wanted to say something. Okay. Oops. All right. All right, thank you. So next would be the mentors for the HackOn data. Please, if you can go to the front so people know who you are and can recognize you.
So this is a Flip team of mentors who are going to help you, particularly in the final 2 days of the event. And we are going to have a quick just intro to everyone here. They are going to also become available on Slack later on, so you can post your questions there, and they will respond whenever they are available. So I'm going to start with Motasam. Motasam was actually part of HackOn data last year too, and he got hired by Flip. So I'm going to ask him to start, do an introduction, tell us how it is so far at Flip after a year, and then pass it to everyone else.
Hey everybody. So I'm working here as a data science engineer, where I started working on analytics and insights, Flip, and then moved to doing reporting for our enterprise clients. And yeah, so I started. I used to help with organizing the Apache Spark meetup, and then with the HackOn data last year in 2016, I also participated in that. And that's where I met people from Flip, and that was got me introduced into this, and then ended up being hired. So yeah, and I'll be helping any of you guys if you want in mentoring in any of the problems that you will.
Hi everyone, my name is Mohammed Anwar. I'm a data scientist here at Flip. I work on the Flip search team, mostly with relevancy as well as categorization stuff. I joined here about, I think it was 4 months ago, so I'm still pretty new here. And yeah, I'll be around as well.
Hey everyone, I'm Dylan Hannison. I am also a data scientist here at Flip, been here 6 months. I work more on the B2B side of things, building out testing measurement frameworks to prove out to retailers all the lovely things we're doing here. I'll pass it on.
Hi everyone, my name is Tazan Ahmed. I'm a data engineer at the search team in Ahmed. And my everyday involves making search better for e-com products on the Flip app. And basically curating relevancy, ETL, and working on Spark. So I'll be around for your help as well.
Hey guys, my name is Asad. I work on all that fun stuff you saw in coupons. So I help our CPG partners make good data-driven decisions.
Hey everyone, my name is Johnny. I'm a data engineer working on the data platform team. So I use Apache Spark, view data ETLs, and dealing with everything around data. So if you have any questions about data format or Apache Spark, feel free to reach out.
Hi, my name is Gloria. I've been at Flip for 3 months after I graduated my master's at Cornell. I'm also a data scientist on the CPG and coupons retailer insights team, so I'll also be mentioned.
Hello everyone, my name is Renaz. I'm probably the newest member of the team. I'm 7 weeks old in Flip, so I'm a data scientist. I have a background in machine learning, so I finished my PhD 2 years ago and then moved to a company doing pure deep learning and machine learning stuff. So we'll be happy to help anyone.
Awesome.
Thanks everyone. So that also answers one of the questions on the Google group that someone was asking if you could introduce the mentors. You can also see the profiles on HackOn Data website. You can also see it on HackOn Data website, and we are going to have some mentors from Loyalty One as well, and we are going to make an introduction through an email for that. So I'm going to pass it to Armand. Armand is going to cover the competition challenge, and then we do questions and answers.
Awesome. Thank you. All right. So I think enough. You guys probably want to get to know what the challenge is. So we thought about many different data sets, and also wanted to bring somewhat what you guys have done in the different workshops and put it to apply. So we found this data set that is very interesting, is large. There are smaller chunks where you can do tests if you want. And this one corresponds to the Amazon's product review and Q&A data. So this is maintained by, so let's just go to the site if we click on it. It's maintained by Julian, and he's a professor at UC San Diego. And then you could, on your own time, look at more details what that data set is all about. I'm gonna cover some of that now. What happened here? Okay, here we are. So there are two data sets. The first one is related to product reviews, and then another one related to questions and answers of those products. So the review data, which is the first one, contains reviews for 142 million, or contains 142 million reviews. And those reviews come from May of '96 to July 2014. So certainly it is a lot of data, and it has several interesting challenges, right? People might be reviewing differently in '96 as they were doing in, they will be doing in 2014. The products, the catalog might be different. Preferences might be different. So what people might be interested in '96 might not be the same 10 years after. So let's look at an example of what the other data set is the one of question and answers, and that one contains questions related to the product. So I'm sure you guys have seen it when somebody asks, somebody bought a bike and they say, well, would this bike fit somebody of such height, or would this baby product be available or be organic, or whatever question you might have. There's a good chance that somebody's going to answer. Of course, different challenges in there. What kind of questions you might be? Are they binary questions, yes or no? Are there questions that could be mined using some sort of text analytics? We saw some of that in one of the workshops, where you could use, say, bag of words to start finding relevance matches. That is the example number one. But you can certainly use other techniques to start, say, sorting through that data set. And what we thought so far is not necessarily to constrain or what the final solution would be. And the idea is for you to also use your creativity. We're going to give you some examples of the sort of things you could do. Of course, one of the first things you could do is use the data to build a recommender system. So in a way, it would be take whatever we did on the lab for recommender systems and sort of repeat that process, but with this data. That is sort of like the baseline, but probably you want to go further. You want to do something different. And well, we'll go over some of those ideas. And then, of course, if you want to throw ideas there, we can put them there. But the idea is that you, as a group, will come up with what interesting products you can build with this data set. So the first one, the first data set contains these reviews, and there are different categories, so books, electronics, etc. And then there is this 5-core, or the data set is split in, or is a filter by something called K-cores. And what that means is that at least 5, in this case, 5-core, 5, such that each one of the main users and items have K reviews each. So if you were to look at any one of them, it would have items that are reviewed 5 times and users that have done 5 reviews. And then you can also look at a much simplified version that only contains the ratings. And that would be sort of, you could do your baseline analysis from there. So one idea could be just say focus on one particular data set. So as you see, there are different sizes. So one of the examples, so if you were to Google around this particular data set, you would find that people have done some work from there. So you could also use that as a baseline for you to get started. So I think somebody started using the lawn and garden category, which is smaller compared to if you were to use, say, books of electronics. So that might be something, say, if you don't have enough computing power, but you want to try a proof of concept, you might choose something on the smaller categories, but then see how that would scale. And that is another important question. You can have a prototype, and that's the idea of this final hackathon, that you would have a working prototype. But then you also have to consider, how can I take this product that is a prototype and bring it to production? What are the things that would take me from the lawn and garden category? What happens if I were to apply that same algorithm to books? Would it work? What considerations would I have to take? Or what happens if I actually start doing some sort of cross combination? And then how do you get there? And all the experiments that allow you to reach whatever conclusion you reach would be useful also as a final explanation of how do you got to your solution. So this is one example. I think all of us here have seen Amazon reviews. So this is, I think it's a music book. And so then it would have the review text, and that is also available. It would have the helpfulness of the review, and then it will have a rating. So in this case, 5 stars. So if we look in more detail, that one, this is what that review looks like. So it's a JSON file. So it would have a reviewer ID. So that's the person who reviewed who did the review. And actually, if you go and click on this particular link, you would actually see that it's an actual review that happened in Amazon. So the product IDs and the reviewers are actually it matches real data. Name of the reviewer, whether that was helpful, the text of the review. Then just from that, you can do a lot of different analysis. So for instance, related to, say, the question and answer, you could start trying to match questions to reviews and see if there is some similarity, and see if whether with a review itself you could answer questions. Yeah, and then the other ones are just the timestamp. And then there is metadata associated to the product itself. So then this is an example again. So it would have a unique identifier for the product, the name of the product, the price, the image. So actually, if you wanted to try something interesting and do some work with images, you could do it because you have access to the image. There is, however, a data set available where the authors took that data set and used a convolutional neural network to extract features from the images. So use that image as part of or building your classifier. So I think they did some of the work. So if we go back to the different papers that were written, one of them was based on image. So image-based recommendations on styles and substitutes. And then you could see the sort of different techniques and ideas that they already tried. All right. And so these are the ones of the visual features that I was talking about. So using a convolutional neural network. And I think there is a total of 4,049 floats. So those would be each one of the final features of the image. And then, of course, you would have the same sort of categories. So you could match them by using the product ID. Then the other data set that is available is the question and answer data set. And then that could be combined with the original reviewer data set. And this is one example. So the question here is, can you use this unit with a GL shaping can? And the answer is yes. If the can fits, the machine will, blah, blah, blah. So same idea here. There will be an identifier of the product ID that you can use to match and then build whatever sort of initial data set or whatever queries you might want to expand from to solve your problem. There are different, as I said, different, if you Google for this particular data set, there are different people that have done work with this data set. So there is actually, this is, I think, an undergrad thesis that just works on the visualization. So I chose two to look at here, but this presentation will be available, so you can click on all the links and actually see them in action. So the first one here is the growth in number of reviews over the year. So this will be just a simple count, but it's sort of what you would expect. As people started using Amazon more and more, the number of reviews increased over time. And then this one here is another one related to time. So here you have all the years from 96 to 2014. And this represents the length of the text of the review. So at the beginning, it seems like reviews were very small in length. And as time goes on, then people started writing longer reviews. So I think I brought this up right now because I think that is the very initial stage that you have to do. You have to do some sort of exploratory analysis, understanding what the data is, and then sort of validating the hypothesis that you might have whenever you set up your problem. So then you could also start seeing, for instance, whether the helpfulness of the review is related, say, to the length of the review, or is there particular categories where or the category that you might have chosen, is there any particular behavior that would help on building your model? Here there's another example, and this was done by Susanna. I don't want to screw up the last name, but you can read it there. And then it was using Spark, so very much what we use. And the final result is available as IPython notebook. And it used Spark and Python, which is exactly what we use throughout the workshops. So you could, if you want, clone that notebook and start looking at it. And this is the one related to the gardening recommendations. So for this one, I'm not sure it would necessarily run on the community edition of Databricks, but for sure will run in your local laptop because it uses one of the smaller data sets. So if you go over it, so first do some sort of data exploration, do some simple counts, histograms, do some, and then preparing the data for machine learning. And finally, there is a recommender system that is built based on some sort of similarity measurement. And this is the one that we use in the lab, ALS, the alternative least squares. And I think this one only used the reviews, the rankings data set, didn't use the reviews itself. But you could use this as a baseline if you are decided to go with a solution or with a problem related to recommender systems. So I'll leave that for you to look at later. And this one is another example, also done using Spark. And this one is extracting features of products from the Amazon reviews. And just for the benefit of time, I'm gonna let you go explore on your own. But the idea there is that you could use this as a baseline for, say, how do you read the data? Even in the original, if you go and look at the review, the data, the Amazon product data website, which is linked or will be also linked on the GitHub. There is, for instance, how do you read the data in Python? So very familiar to what we've done. So this one is particular to pandas data frames, but I imagine you could, in principle, build something very similar to read into Spark data frames. So we already talked about some of the ideas. As I said, going back to the base idea of constructing a recommender systems, but also you can start looking at from the point of view, say, of the merchants, not necessarily from the user. So you could think of building some sort of analysis for the merchants to decide whether they would have a competitive advantage based on the type of products that they might have, or whether a particular product would sell based on what the reviews are. And then in principle, I mean, it's not a direct inference, but you could in principle have an idea of what are the sales of a product based on these reviews. You do have the ranking of sales per product per year, the ranking of each product per category. So you could do something there. You can start thinking of predicting the rating of a review given previous ratings of the product or the user. So sort of using the temp component of the data. And finding interesting recommendations for some specific categories. So the example of the garden category. And or incorporating the images. So certainly there are a lot of different places where you can expand your idea. But I think important to that is how are we going to evaluate the final product? So there will be I think at some point we'll pass the the full agenda for the 2 days. But the idea is that you would start working from today until the day of the hackathon. You would have some initial feedback, and that initial feedback would allow you to do some fine-tuning on the Saturday, so the first day of the event. You will take that and then go into the final presentation.
To actually explain the whole process. So now that you have the challenge, you know the challenge, and you have the data set, what's going to happen is that now, during the networking time, if you haven't found a team yet, find the team, and start working on studying the challenge, studying the data set, and start working on an idea. When we get into the event, during this time, before the event, you can ask questions on Slack, on Google group. If mentors are available, they will respond to you asynchronously. And then during the 2 days of the event, the first day, what you are doing in the first day, you are basically finalizing your solution. And you will have opportunity to meet with mentors. They will give you feedback in person, and they work with your team. They will answer your questions. They're not going to do the work for you, but they are experienced. They will help you a lot with the solution that you're coming up with. The second day is going to be when the judging happens. So, and for judging, we have 2 stages of judging. One, preliminary judging, when we will choose only top 5 teams from all the solutions, from all the teams. And then after that, we will have a public final judging, where the top 5 will present their solution to everyone. The first one is not to everyone. The second, the final stage, is to everyone. So you will present your solution. And when you're presenting, the judges in both the stages, that's what they are going to use to evaluate your solution. So you need to understand, you need to understand the problem well. You need to have a hypothesis and assumption and articulate it well to the judges and have that in your presentation. You need to tell the story of, okay, what are the ways, what are the paths that you explored, what are the failures that you had, and why you came up with this solution at the end. You need to explain that. They are going to look at your implementation too, so it's not, just understanding the problem. Your implementation, your code quality needs to be good too, and you need to demonstrate the result visually for people. So something to note is that the feedback that you get is mostly from mentors who are technical. And the first stage of judging is by mentors who are technical. The final one is not necessarily just technical. It's high level too. So when you are preparing your presentation, your solution at the end, you need to take that into the account that I'm going to actually show my solution in a way that will make sense to anyone who has any ideas about, a product, who has a high level understanding of the business and the problem. So you need to visualize that well. And then you need to come up with your plan. Let's say you can't process 1 terabyte of data on your laptop, that everyone knows that. You come up with a decent prototype. And then at the end of your presentation, you say that, okay, if we need to productionize this is the plan to make this solution scalable and work in a big cluster with a large data set. And these are the estimated difference in performance of your solution, for example. I'm giving examples. So you need to come up with a plan for your productionizing your solution. So that's it for the process. Any questions about that process? Diego.
I guess since we can choose any type of problem, I think also the complexity of the problem we are facing should be considered by evaluation criteria. Is that correct?
Yes, definitely. And we have talked about it before. What's going to happen is that Armando is going to give you a seed problem. Do you want to add something here?
No. I mean, if you do only say what those examples that were shown there, certainly that is the baseline. So something better than that is expected, and certainly we've seen the kind of work that you guys have done, and that's what we expect.
So take that as the bar. You need to go above that.
Okay.
Yeah. Yeah. So that's it.
Yeah, no, I don't think we have anything else. So I think we can go over more specific questions. I think there were already some questions that people had asked on the Google group, and some of them I think were answered here. But we can go into more specific. I think it related, say, to the group size. That is clear. That is 2 or 3 maximum, and I don't think, or unless somebody has some. Now we can go into specific questions before we go into reviewing the lab. Everything is very clear. It seems good. All right.
So
yeah, question.
So you told us what the evaluation criteria is for the line of 5. What's the evaluation criteria for selecting
The same. Yeah.
So this is a very general way of evaluating basically any solution.
Right.
So should we use any type of web UI or UI for our products, or how it works? Are we limited to something, or should we use Databricks platform?
So I don't think we have any limitations. So it's whatever gets you faster. I mean, we understand that this is a short period, right? 2 weeks. And one of the things we notice is if say the problem is only given on the day of the hackathon, you might not be able to run experiments and work on your solution. So that's why this time we're giving a little bit extra time, in part also to get you to get to a better solution. But at the same time, get whatever you're comfortable with and get that running. And remember that this is a prototype at the end.
So it doesn't matter in the evaluation, let's say if someone has a UI or something.
That's definitely, if it helps with visualizing your
Yes.
result, if it communicates your results better, definitely. Anything.
Yeah,
if you can use a piece of paper to communicate better, then use that, definitely.
But I would, I would rather to work on the data science part than the UI part, right? So I just want to make sure whether that affects the
So you don't
evaluation.
necessarily need to make a UI. So when you think about evaluation, you think about visualizing your results and solution in a way that you communicate with the judges and mentors. So I see where you're coming from. You want to see whether you need to focus on the data science part of it. So you need to also focus about communicating your solution with people too. So even if you're working on a data science problem, let's say you are in a team, you are a data scientist, you gotta talk when you are going to your manager, let's say head of data science, you have a solution, you also need to show the results of your solution. You gotta visualize it, you gotta communicate it with the team as well. So anything that helps that communication, I would say use it, that's an extra. That's a good thing to do.
And how many members does each team have?
2 or 3.
So I would say stay at 3. Don't go higher, because 4 becomes a little bit more difficult in 2 weeks in the time that we have to. Any other questions? How many of you are confident that you got it right now, based on what you said? Raise your hand.
That you understood the problem.
You understood the problem, you understood the process. Okay. Raise your hand high. Like, go high. Okay.
Okay, people are.
Okay.
Good.
Okay, good. If anyone has any question that you don't want to ask here for any reason, if it's specific, ask us later on or post it on Google Group. Okay?
Good.
Sounds great. We'll move to
The last part, yeah.
stuff.
Wow, we're doing pretty good with time. So thank you to the mentors, and yeah, we'll be hearing more from you, or you will be hearing more from us in the coming weeks. Thank you. Yeah, thank you. So Mutassim is going to tell us about this week's lab. I hope If you have any questions related to the lab, please ask them now. Oh, do you mind opening the
Solution here.
no, the what's it called?
Zoom.
The Zoom, yeah.
So in the meantime, until they set up, I'm going to quickly also go over the Google group questions. So one of the questions that I thought was important was,
So if you go to the GitHub for the HackOn data,
for the final event, like just show up for 2 hours, that's not possible. No, you're going to be there for 2 full days.
GitHub HackOn data /GitHub/HackOn data /
Anyone had a question on Google group that we didn't answer? There you go.
Whether the,
and
the
Zoom.
points that we earn.
No,
Yeah.
okay.
Yes.
I remember that.
Yes.
No, so the points are for recommendation to the sponsors. The points are completely separate from the final project. But the final project matters. Like I can give you an example. Last year, I think the first or the second team.
No, but I'm gonna move it.
So guys, look at the final 2 days event as an opportunity to show your skills. The workshops are good, doesn't mean necessarily you can work on a product on your own. So that's a very good opportunity to communicate that with the sponsors. Show your solution, show your presentation.
So now exit full
Any other
screen,
questions?
and then share screen, and then desktop 1, share screen at the bottom.
I need to choose,
No, but you can leave the whole desktop, that's fine. And because if you change tabs, otherwise it gets lost.
You ready to start this?
Okay, it's good.
So you want to take a 5 minutes break? Ready? No, that's it. You're ready to.
No, this is a different size. So hey everybody. So last lab. How do you guys thought of this lab? Like, was it too difficult compared to previous
Can
ones?
you guys all hear what people talk here? Anyone who has problem hearing? Okay, can we up the volume here a little bit? I feel like it's a little bit, just
You have to talk really close. I think. Yeah, that's it.
Okay, so this is like, I think this is a very interesting lab compared to previous ones, and having being the last lab also, like, it's interesting to be able to say we've covered all of those topics confidently. Now we understand all of these things that we've covered in the past 7 or 8 labs. So this is about PCA, which is a dimensionality reduction technique, which is very important in like doing the real data science work. We always work with highly dimensional data, and we want sometimes to reduce the number of dimensions so that we can work easier with this data or apply different techniques on this. So I will just go through the solution like step by step, and if you guys have any questions throughout, stop me and let me know. Okay. So this is like they start here with just preparing some data, some 2-dimensional data that you can create with some covariance. So this is just this a function to create the data, and here they're creating the. This is the So this is here they're creating the covariance of -1. So it's like identical data that's very, very correlated to each other, and we're visualizing it. You can see that it's, even though they are coming from 2 normal distributions, they all lie on the same line here. While if we change the covariance to 0, we can see that it's totally random data. There is no correlation at all between the 2 distributions here. I hope this is clear. So yes, so now the interesting data that we work with is the correlated data. It's not totally random and not totally
correlated. So it's like they set the covariance to be 0.9 here. And we can visualize this to see that there is a correlation between the two distributions, although it's not totally correlated. Then we move on to actually something that we have to do first before doing the PCA algorithm, which is standardizing the distributions. So basically, we want to, regardless of what the mean is for each of the distribution, we want to just transform those distributions to have a mean of 0 always. And to do that, we just get the sum of the data and then divide by the total count. So there are a couple of ways to do this. This is one way where you do the sum and then divide by the count, or you can just right away use the mean, dot mean. And if you remember, correlated data is a two-dimensional data, so you have two columns or two features. So sum will actually sum each on its own, and then you will get a two-dimensional mean. Two-dimensional data the same, but it's centered around the 0 mean instead. For the next step would be to do the calculation of the covariance matrix. And this is how the covariance matrix is defined. And in the lecture, there were explanation of this and the derivation of why this is actually the covariance matrix. However, when we do the calculation of this, we don't actually take our data and transpose it and then multiply it by each other. We do something different here. They're giving us a hint here. It's like to use the outer product of the data set. So basically, we're taking each data point, and doing the outer product with itself. That will give us a square matrix. And then we take the mean of all of these matrices after we add them together. That will give us the covariance matrix. To do this is, again, after we transfer the data to have a 0 mean, we do exactly that. We just do the outer product of each of the data points, then we take the mean over all of the data points. Any questions so far? Yeah, please.
So is that the same as doing the actual numerical computation, XT, X transpose T times X?
Exactly, yes. And then you divide by n. That's exactly it. The same, instead of doing an expensive matrix multiplication and matrix transposition. And if you think about this, this is maybe not easy to distribute. While if you do the map here, it's very easy to do on a distributed environment. So taking you're performing an operation on each of the data points, and then you're just taking the average or the mean of all of them. So you get the same. And if you remember the definition of the covariance matrix, it's symmetric. So this value should be identical to this value. And these two values are basically, and the diagonal values are for each of the dimensions. This is the variance for the first dimension, this is the variance for the second dimension. And this value is the covariance, or the correlation between the first and second dimensions. And if you have a 3x3 matrix, it will be also similar, like first pairwise correlations between the dimensions. So now we understand how to do the covariance matrix. This is just putting it all in one single function. So basically, we're just doing exactly the same as we did earlier, but now in a function, we pass it the data, RDD, and then we do the same thing. We centralize the mean to 0. We do the outer product, each data point with itself, take the mean. That will give us the covariance matrix for this data set. Is this clear so far? Okay, so next they talk about eigen decomposition. This is one technique in linear algebra that will be used for PCA. I mean, we'll not get into the details of what is eigen decomposition, just like enough to know at this stage, like there is a function in NumPy where you can call this function is actually works pretty well on symmetric matrices. That will give you the eigenvalues and eigenvectors for that matrix. And this is the first step of getting the PCA, the dimensionality reduction, because those eigenvectors, we will later see how we can use them to take the top k of those to reduce the dimensions. So what's required here is to get the eigenvectors and take the top one, what they call the top component, which is the eigenvector with the highest eigenvalue. So basically, we just call this function with the data. We get the eigenvectors and the eigenvalue. And then we get basically we need to sort the eigenvalues and get the eigenvector that corresponds to the highest eigenvalue. And this is what we're doing here. Argsort is that will return to us the indexes of whatever we pass to it, as if those values were sorted. So we're taking the indexes of the eigenvalues sorted. This is sorted ascending, I think. And then we're taking the eigenvector that is in the last position, which is the highest in this case. So the highest, the vector that corresponds to the highest eigenvalue is the top component, or the first principal component of this data set. So doing this will give us, these are this is a two-dimensional data set, so we get two eigenvalues, and we get two eigenvectors, of course. And here, this is the top one that we get when we take the last index here. Is this clear? Any questions on eigen decomposition? Yeah, please.
So did you say this for the highest eigenvalue or the first, let's say the first 10 eigenvalues?
That comes later when we take when we can pass how many dimensions we want to reduce to. But here in this section, they're asking specifically about only the top one. So here, this is the top one, which is the highest. Now, once we have the top component or top k components, we can calculate the PCA scores for the data set. And that is basically here. So, data set, we got the top component for that data set. So now if we apply that, it's kind of, we want to project this two-dimensional data set onto a single dimension. So that when we get we convert each data point, two-dimensional data point, to a single number, which is a one-dimensional data set. So basically, we just do a dot product, each data point dot product the top component, and this will give us since here top component is just a single value, we'll get one-dimensional representation of this data set. Now, this is the generic PCA function. Here, we're not limited to just one top component. Here, we can pass in a number k. K, of course, needs to be less than or equal to the number of dimensions we're working with. And we want here to add, to write a function that will return to us the top k components or principal components of this data set. So following everything we've done so far, this is easily like we have to get the eigenvalues and eigenvectors. We have to sort them again. Now, after sorting, we're just reversing the order here. And then we take the top k out of those. And then once we get the top k components, we take the dot product of each of the data set, of each of the data points with that component. That will give us the the data set will return to us a data set, but in a lower dimension representation of this. And in this case, we're returning the top K components and the new representation of the data set in a lower dimension space and the eigenvalues. Is this clear? This is very similar to what we did earlier, but just all combined. Yes?
For line 21, why do you have to use 2 colons?
Again? So
For line 21, why do you have to use 2 colons?
Just reverses the.
yeah, so colon -1 means reverse the order, Python. So if you remember, top here we said we took the index -1, which is like just give us the last element. Here we're taking a different approach. Instead of taking the last K elements, we're taking the first K elements, but of the reversed list, which is the equivalent.
Just another question. There was a bit of confusion this week as to by largest eigenvalues, do we need to give largest absolute value for their eigenvalues or raw value? And I mean, I read the paper that you posted, and it seems to suggest that you need to get the absolute value.
Actually, I didn't think about this, but when I sent that email, I didn't consider whether the absolute value is already calculated by the library that we are using, because the link that I posted, they were calculating the eigen values manually. Yeah. So maybe
if it's a correlation matrix, if we have a full rank matrix, then all the eigenvalues would be positive.
Oh,
so it's an identity. So we don't have to worry about that.
Would you like to repeat that lab for everyone to hear?
So usually covariance matrix is symmetric matrix, and so there is an identity which says that all the eigenvalues have to be positive, so it's called positive definite matrix. So any matrix that has not positive definite, you would see that it's all the eigenvalues are positive.
Okay, thanks. Okay, so at this stage we have written a PCA function. We can give it an RDD, a data set, and give it the K that we are telling that we want to reduce this K with this n-dimensional data set to a K-dimensional data set, and it will return to us this data set. And here is like just a simple test. We have this 4-dimensional data set, and we're projecting it on 3 dimensions. Yes, 3. And we're getting the representation in lower dimension space. Okay, now since we have this function now, they're just applying it on the random data that we generated earlier, the data that has 0 covariance. And I'm not really sure why they did it on 2, like, because this is a 2-dimensional data and they're calling the function with 2 as well. So they're not reducing dimensions here. So, but I think this is just to show us that we can apply PCA with the same number of dimensions. This will only transform the basis of the dimension space that we're working with to make it like to do the same thing, like just the first component will be the one responsible for the most variance of the data. So just instead of using the normal dimensions that the data was generated in, we can transform it to a different basis for this. So we could have called it with 1 here to reduce the dimensions, but we were calling it with 2, same dimensions, but we're getting different basis for the dimensional space. And here is the visualization of this. We're taking 2-dimensional data and reducing the dimensions to 1 and visualizing it on top of it. We can see here that the correlation here is clear that we can think of this as a projection. So we're projecting these two-dimensional data on this single line here. So in this case, the two components are these two perpendicular dashed lines, and we're taking the first one, which is this axis, and projecting the two-dimensional data on that. So we're getting just a single dimensional data. We're doing the same with the random data with covariance of 0. We also get a different set of top components, but the same idea applies here as well. Two-dimensional data represented as one dimension. We're reducing the dimensionality. So here we can see the difference. Like here, it's clear that there is a correlation, and this one-dimensional projection can explain the data better than this one, for example, where the data is all over the place. So later on, we'll see how that can be actually calculated, or we can explain how much of the variance is attributed to each of the top components. So similarly, with three-dimensional data, we can project it onto two-dimensional space. So here we're generating 3D data. This is the covariance matrix that we're passing to the random generation function. If you notice, this is the variance for each of the dimensions. And then those are, this is a symmetric matrix. These are just the correlations between the pairwise dimensions. And this is the visualization of the data. We can see that it's kind of clustered around the single plane here, with some variations on the third axis. But in 3D, basically, without having this plane here, we cannot see that. So that's what PCA will let us do. So this is very simple. Using the function we created, we pass the 3D data with the two dimensions in this time. That means we want to reduce dimensionality of this data set to 2. And this will give us actually 3 vectors of 2 dimensions each. So those are the top components here in this case, and these are the corresponding eigenvalues for those. Now, if we take the same data, but now present it on a 2D, and here they're using the color as an indication of how far it is from that plane that we've identified. So this is, just think of this visualization here. If you take it and rotate it in a way that makes this the plane, then this is how we will get it. And the basis for this 2D plane is the top components that we've calculated in PCA. Any questions on this? Okay. So here comes the interesting part. Here, although we know how to calculate the top components of any data set given to us now, we still haven't talked about how to measure what percentage of the variance is attributed to each of those. We said that we always take the top K, but then sometimes we want to know how many, what is K basically, for example, if we want to explain 80% of the variance for a certain data set. So that will allow us to do that. This is basically a very simple idea where we take the sum of those eigenvalues of the top K eigenvalues and then divide by the total. Take the sum of the top K over the sum of all the eigenvalues. That will give us a fraction. That fraction corresponds to basically what the variance that is explained by those top K components. So just an example on this. We go back. So here, for example, so we know that these are the values for the these are the eigenvalues. If we sum them and then take this the fraction of the first one over the sum, that will tell us how much of the data values is represented by the first one. Same thing for the first two. And of course, this is 2 dimensions, so it will give us 100% if we take 2 top components. Do we still have time to go through the next set?
Yeah, I think we
have. Yeah, 15.
Yeah, so the next starts at 8:35, so you got about 15 to 20 minutes.
Okay, sure. So here, now we're starting to play around with like real data set after we've built already the functions that we need. So here we're reading the data set that's provided. The way that this is structured is that each line in the data is basically one big string with spaces. So we're taking basically just parsing it. We're taking the coordinates of the first 2 values are the coordinates of the pixel that we're working with, and the rest of the values are kind of a time series of the intensity of this pixel over the next 240 seconds or so. So yeah, so this is just parsing that data, a single line of the data. We can use this to create an RDD of this data for us. Here we can see what is the maximum or minimum of the intensities of over all the pixels. I hope this is clear. So here the x1 is the actual x1 is like the resulting of the parse is a tuple. The first element of the tuple is a tuple of coordinates, and then the rest is the list of intensities. So here it's like we're getting the list of intensities as the second item in this tuple, taking the minimum of that for each data point, and then taking the minimum of all of them. This is just to tell us what kind of range of intensities we're working with. Here we're visualizing one such data point. So for just selecting one of the points that have some activities, one of the data points that have standard deviation greater than 100, sorry, so that we know what we're getting some change in the intensity over the time series, and we're plotting this to see that kind of activity over the entire. Yeah. Yeah. So here we're dealing with the intensity levels. We saw here, for example, we have intensity levels from 300 to 700 for this particular one. We have overall from 100 to 940. Here we're trying to just normalize this. So we have them centered around 0, and have the intensities like go below and above 0, so that's easier to work with. So we just reduce the mean to 0. And to do that, we just get the mean. And for each data point, we subtract that mean. And we produce a new time series with the transformed mean. Is this clear? Any questions on the data, the way we parse it, the way we process it? So again, taking one data point and visualizing the activity here, we can see where we had like values going from 300 to 700 or something. Here we're getting something around the 0, so from minus 0.1 to 0.4, 0.5. Here we're just picking one particular data point. If we somehow save the original data point that we graphed earlier here, and then after normalizing, we graph again here it will be exactly the same graph, just with a different scale on the axis. So now we have this data that is 240 dimensions. Now we have our lovely PCA function that can reduce this 240 dimensions to a number we want. So we're passing this with the number 3, so that means we want to reduce it to a 3-dimensional data that we can work with. So it's just one call to our PCA function, and we pass it 3 to get 3-dimensional representation of our data. And the rest here is they're trying to visualize this data set. So we take this reduced dimensionality data set and then we visualize it. So we see overall certain areas have more intensity, or although we're not talking about intensity anymore because we reduced the dimension, so we're talking about something else. But we can see that there are some pixels that have more activity than others, and that was reflected, of course, in the original data set in 240 dimensions, but here it's easier to work with only on the 2 dimensions. Same thing here. This is so this was only the top principal component. This is the second one. And this is, yeah. So here they're doing something to color the different pixels based on the activity of the reduced dimensions. And this is the visualization they get using that data set. Okay, any questions on that before we move on? So here's an interesting part where they use the kind of matrix algebra to do some aggregations on the data. I mean, basically, the way they explain the data is it's 240 seconds, and there were 12 stimulations for the 12 visual patterns that were presented to the fish over this 240 seconds. So we're working with 20-second periods. So instead of taking the entire 240-second period and work with that, we can divide it, split it into 20-second periods, and work with that to see if we can find something interesting about the data. And to do that, they're introducing a few of the NumPy operations to manipulate basically matrices. And the way to do this, I mean, it's difficult to explain here. Like, you actually have to get a piece of paper and write the kind of the matrices that you have to do the transformation that require. So basically here, for example, for this one, they want to do the sum of the 0th, 2nd, and 4th elements, and then the 1st, 3rd, and 5th element. So you need to think, what is the matrix that I can use? If I multiply it by some data set, I will get in the first index, I'll get the first sum, and then the second index, I'll get the second sum. So basically, when seeing the solution, it's easy to visualize. Like here it's 1, 0, 1, 0, 1, 0. That means when I multiply this vector with my data set, I'll get the sum of the first, the 0th, and the second, and the 4th, and same thing for the second row. And so here they're just walking us through understanding what those operations can do. So here we can see that if we want to some particular elements, we can put 1 in those locations and 0 otherwise. If we want to do something like, what is this one? This is the same, just put ones where we want to add. And here it's same thing. I want to add the first 3 and then the second 3 and the second element. So we add 1, 1, 1, and then the second row will be 1, 1, 1 at the last 3 places. And finally, this will give us the sum of the first 2 elements, the sum of the middle 2 elements, sum of the last 2 elements in a 3x6 array. So yeah, I mean, for this you have to either know how to do this or just like work through the one example and see what is happening when you are trying to multiply these matrices of 1s and 0s. And similarly with the numpy tile and I operations. So tile basically takes one matrix and tiles it. How many times we ask it to, like we can pass a number to the tile operation and it will just put them next to each other. And I is the unit matrix here with a certain dimension. So we can see how we can use those operations to produce what we were producing manually here. Is this clear? Is this confusing? Is it? Okay. So what we created earlier, for example, this is to sum every other element. Remember we had 1, 0, 1, 0, 1, 0. We want to reproduce this using tile and I. So if you see, this is very simply 1, 0, 0, 1. If you consider this as a 2 by 2 matrix, and then tile it 3 times, we're getting this output matrix. Similarly, for this one, this is a unit matrix of dimension 3. If we tile it twice, we get what we want, and this is exactly what we are doing here. And having done this, we know what this will do and what will this do. So now we have a tool that will tell us if you ever want to sum every other element, you just use an MPI2 and then tile it as many times as you want according to the data set that you have. Similarly with summing every third element and so on. Any questions on this? So cron is another interesting operation here where we can define multiplication, I mean, different kind of multiplication. This is a generalized matrix multiplication. You can see like it's easier maybe to understand visually if you multiply these 2 matrices with this operator. That's what you get. Like you get this one tiled this many times, but then for each one it's scaled by the ith and jth element of this first matrix.
Is that a numpy operation or special spot?
No, it's a numpy. Everything you're doing is numpy cron. I mean, this has a mathematical formulation behind it, just like numpy took that and implemented it in a way that you can just apply directly. So again, we'll try to think on how to do the sum by 3 and sum by 2 using this operation. Again, it's maybe not readily obvious how to get to this, but if you have like a piece of paper and a pencil, you can write it down and see that this actually gives us what we want here. So if you take I think they give us a hint to use ones here. Yeah, so we need to use ones, they're telling us. So basically, ones is just this NP ones. This will give us this part, and then we're multiplying this by the NPI of 2, which is the unit matrix of 1. So we'll have 1, 0, 0, 1, and then imagine that similarly here, 1, 0, 0, 1, and that is multiplied by 3 ones here. So we'll have 0, 1, 0, 1, and then 3 ones here, 3 zeros here. So you will get something like this. You get the ones and the zeros, and then the zeros and the ones. Is this good? I mean, is it like obvious here now? By now, it's how are we getting to this? Okay, so similarly, we're doing the sum by 2 again. We need 1, 1, 1, 1, 1, 1. Okay, so now having learned how to use all of these operators to create those kind of matrices that we can use to split and slice our data. So here they present to us 2 different ways we can aggregate our data. First is by time. We said like we have 20-second periods that we can aggregate on. So basically we want to take the sum every 20th element of the data. So that means we want to multiply the tile unit matrix of dimension 20 12 times to get that. And once we have this transformation, we can just take the dot operator of dot product of all the data sets with that one. This will give us another data set that is, the result is the summation of every 20th element. And here we're using that to give us another representation of the data. So instead of working with 240 dimensions, now we have 20 dimensions. But even 20 dimensions, we can even reduce them by using PCA to get 3 dimensions in this case. But we know that these 3 dimensions are coming from applying PCA to the 20 dimensions data that is split by time period. For example, if we know that every 20 seconds we have an event that's happening that might cause some activation in those pixels, then we can analyze this based on this time division. And this is the visualization we get using that. Another way to cut this data is by direction, by like the stimulus they're using. So there are 12 visual patterns they used. So we can take the sum of, for each one of those visual patterns, we can take the sum over that. And to do this, we're using the cron again, like we used it earlier, to aggregate the data per visual pattern that was presented. And again, this will give us another data set that is of a lower dimension than 240. This would be 12 dimensions. But then again, we can take that and apply PCA to reduce it even further and get another visualization here. So each of these visualizations represents something different. First was split by time, and the second one split by the visual pattern that we're using to stimulate the fish. And in both cases, we used PCA at the end to reduce the dimensions to something that we can visualize easily with the colors. I guess that's it, right? Yeah, so this is the last of the slab. Any questions? Anything confusing? Here. Okay, thanks. Thanks.
So I think that's it. You want to close it?
So I want to thank Flip team, particularly Kristen sitting back there. Give her a good round of applause. We're doing a lot of work for making this happen. So thanks everyone for it, and thank you all.
I hope it's providing value for you. I see that about 55, 60 people have survived 8 weeks of workshop. Not everyone makes it after 8 weeks. You have made it, so you are the best of that group. Give yourself a good round of applause here. And after this, we are going to have networking for 30 minutes. Good time to find your teammates if you haven't.
Okay, thanks everyone.
So maybe if you don't have a teammate, raise your hand and